The purpose of this demo is to illustrate how data engineering can be used to solve some of the issues with traditional actuarial workflows. The aim is not to demonstrate the solution, and hence some of the details have been deliberately de-emphasized in the demo. The focus is just on the purpose I've listed above. The demo relates to downloading and processing the weather files, which are quite large and involve special multi-dimensional format. Uh, so yeah. So the traditional method is the brute force method, which we actually use quite a lot. So we'll have all the data in one place, download the files, process what we need out of it, and then ask the DBA to put it in a database or provide us the flat file so that we can do the analysis. But this is fraught with problems for the reasons I've listed to the side. So there are large number of files. What if errors happen? The things would take a lot of time, etc. So this is the amended distributed method. This may not be the ideal solution. But this is one solution which improves on the previous one. So this is a distributed method. Don't focus too much on the specifics, but the workflow, which I've put it in red. So the files are to be downloaded are listed in Excel. It allows us to use Excel as the control mechanisms of what files to download. We could use the Excel functions to extract the dates out of the URL. The files are stored in the cloud on S3, and there are lots of files, so you need a selection of the files, maybe pertaining to a particular region and for particular dates. A separate R process downloads these files into a folder called downloads. Another R process, totally separate to anything else, uses the command line tools to process the downloaded file from the download folder and saves it into the output folder. So these are not simple calculations. So command line tools are available for these weather files, and we leverage on those command line tools to extract only the data that we require. So in this slide, what I am looking at is that I've listed out the potential benefits of using the method suggested. One change that you would notice is that there are multiple R processes, both on the downloader side and on the processor side. These are independent processes, and the by multiple processes, we mean that the structure is such that the whole solution can be parallelized. So the first benefit is that it is fault tolerant. If some error happens, then we could just stop the process and rerun it. Or even if one process out of the many processes fails, then it fails graciously, so it doesn't impact anything. The other thing is that it is intuitive. Each of the element of the solution does what it does best. The downloader downloads the file and nothing else. The Excel just controls the files to be downloaded. The processor processes the files, and then we leverage on existing tools. There is minimal coding involved. If we had to write a one big solution code to run all this, there would be many variables, things would be dependent on each other, and much of the parallelization would be lost in there. The solution can be parallelized, that is, they can run on multiple computers or on the same computer at different times, and the results could be combined or amended as well. The processes can be chained. So after output, you could have three more processes, and you just add more R5, R code or Python code or any other thing, and the workflow will run. The processes are asynchronous, so no process stops the other process. It is API friendly, so I could write a API on top of it to control everything, triggers could be set up if certain conditions are met. Version control can be done. The code could be written to Git, etc.